Okay, 5-7 day 2. This is going to pick up a little bit. These are a little trickier. I left the rules up top for you for easy reference, and now we're just going to talk strategy. Okay, so let's look at this and let's pretend it's not from 5-7 day 2. How would we know how to do this? I want your first thought to always say, let this be you. If that's you, I'm going to get a negative 2x plus 4, which is not in the problem, which means that won't work. So what that means now is I'm probably going to be using some inverse trig. Which one does this look like? Now, none of them actually, right? We can for sure say it's not arctangent because we have a square root. And it looks like it's not arcsecant because we don't have a variable in front. So I'm guessing that it's arcsine. But we need something squared minus something squared. We don't have that here, and we did yesterday. So here's where we're going to get a little fancy. We can complete the square. Do you guys remember how to do that? Okay, what we're going to do is, let me give you an example up here. If you have x squared plus 6x, if you have to complete the square, what you want to do is you want to take half of the middle and square it. So half of 6 is 3, and 3 squared is 9, but whatever you add on, you also have to take away, right? You can't leave that there. Okay, so then this final answer would be, this now can factor to be x plus 3 minus 9. Okay, so this is, we have not changed anything. This is how you complete the square within the problem so that you get a perfect square. If we can do something like this, then it's going to match up with what we're thinking here. Okay, that 2, I like my scalars out in front. Let's go ahead and write that there. Okay, now to do this, I am going to take that negative out. And I'm going to have x squared plus, oops, if I took the negative out, shouldn't that be x squared minus 4x? Okay, now to complete the square, you're going to take half the middle term and square it. So what's half of 4? It's 2, and what's 2 squared? 4. Now I just changed the problem. And you know what? Let me put this in another color. I like that blue. Let's do this. I changed the problem right there. Because I changed it, that's totally illegal and I have to fix it. But I didn't technically add a 4. Do you guys see this negative? So I really subtracted 4. You have to be careful with that. So then I'm going to add the 4. I'm also going to be certain not to forget my dx. Okay, now let's see, why did we do this? So if we go on, look at how we can rewrite the bottom now. Because the subtraction is in the beginning, I want that to come last, so I'm going to write my 4 first. So it's going to be 4 minus, now the whole reason I completed the square was so that I could factor it to be x minus 2 squared dx. Now do you guys see that our thought that it was going to match up with arcsine is spot on? I have a number squared minus a variable squared. Ta-da! Okay, going on, matching it perfectly, we are going to say 4 is 2 squared, so a is 2. We know that u is x minus 2, so du is dx. If I go ahead and rewrite this, this is the square root of 2 squared minus u squared, du is dx. Now I can use arcsine. Remember, arcsine is the only one that does not have 1 over a in front of it. So it's just arcsine of u over a, but my u is x minus 2, and my a is 2. Okay guys, welcome to 5-7 day 2. You can see it really picked up. So as we're going through this, I'm trying to point out tips to you. I want you to be like just aware of them. And if you have any questions, let me know. Like if one of the tips doesn't make sense. Okay, going on to B. What are we going to do with this one? Okay, I would say let's let this be u. Remember, when we see this, we're not going to know it's from 5-7, so we have to think, what would we do? If u is x squared minus 2x, the derivative would be 2x minus 2, which this is in the denominator. It's close, but it would have to be in the numerator. So u sub does not work. Okay, what's my next plan? Arctan, gone, not going to work. I see I have a square root with an x in front of it. What are we thinking it is, guys? I agree, arcsecant. We don't know for sure, but that's our thought. But arcsecant has a variable squared minus an a squared, so guess what we're doing again? You got it, we're completing that square. So 1 over x minus 1. Square root. What is this going to be? X squared minus 2x. If I complete the square, I'm going to add 1. Because half of negative 2 is negative 1, and negative 1 squared is 1. But then I better subtract it so I don't break any math rules. dx. Now 1 over, this is x minus 1. This is the square root of x minus 1 squared minus 1. Now, is this looking good? Oh, I'm loving it. Look up above. We have u squared. This is my u. This is my a. Everything's great. Off to the side, a is 1, because square root of 1 is 1. U is x minus 1. Du is dx. And how about we fix this to make it look like a u and not a v? So if I rewrite this out again, I'm just trying to match rules. This is going to be u. This is a square root of u squared minus 1 squared. Dx is du. I'm loving this. Not too bad, other than completing the square. Going on, our final answer. Does arc secant have 1 over a? It does, but a is 1, so it doesn't matter. So it's the arc secant, absolute value of u, which is x minus 1, over a, which is 1, plus c. Okay, I left you a lot of space here. Going on to C, we only have 3 more examples, so we're 2/5 of the way done. Okay, let's look at this one. Remember, we're pretending we are not from this section. Okay, what would we think? We would say, well, it looks like u could be x squared plus 2x plus 2. Does that work? What is du? 2x plus 2. But what do we want dx to be? I'm sorry, dx is 2x plus 2, but what do we have? Oh, look, we were so close. If only they wrote a plus 2, we could use natural log and this would work out just fine. But we can be a little crafty and say, well, what if we make it plus 2? So notice on this one, unlike the other ones we just did, my du was really close to what I have. It's just off by a number. That was not the case in the other ones. So on this kind of problem, when you're so close and just off by a number, you're going to change the top to be what you want, which is 2x plus 2. Again, illegal. We just changed the problem. What do I need to add on to the top to take it back to a minus 5? You're right, minus 7. All over x squared plus 2x plus 2 dx. Notice we did not change anything. Remember when we completed the square, we really didn't change the problem. Likewise here, -5, -5. Now, I want this 2x plus 2 to be on top of this. So remember, we wanted this to be a 2x plus 2. So what I'm going to do is split out this integral. So it's 2x plus 2 over x squared plus 2x plus 2. Then I'm going to take away 7. I'll write it like this for now, and then I'll fix it in the next part. I split up the integral. We've never done something like this before, but it's the only way to do this problem. Now, from here on out, guys, I'm going to work the 2 separate problems because we're going to approach them differently. So I'm going to start on the left. And remember, my whole point of having a 2x plus 2 up there was to have the u. So I can rewrite this as u on the bottom. Look, I'm going to try to show the top also. So I replace this with u. You know, like crossing stuff out. Oops, did not mean to cross that one out though. Let's fix that. And let's do another fix. That was supposed to go there. Okay, so I'm on the one above. I took that out. Now look at 2x plus 2 dx is exactly that. So then I have a du. I know how to integrate this. It's natural log of absolute value of u. Now technically plus a c, right? And then I would replace my u, and I'm going to get x squared plus 2x plus 2. Okay, I'm done with the left side. Now on to the right side. I'm going to factor that -7 out in front like I always do. Now this one is not u sub. If I take the derivative, I have a 2x plus 2, and there's not an x. So this is going to be an inverse trig. Let's go look up here. Which one does this look like? There was no square root, so right away, gone, gone. We're with arctan. Okay, so I want a number squared plus a variable squared. Guess what we're doing? Completing the square. So this is going to be x squared plus 2x. What do I want this to be? Half of 2 is 1, and 1 squared is 1. But I was just illegal. Then if I added a 1, I changed the problem. So then I'm going to subtract 1. But what else was in the problem? Look, I had an x squared plus 2x, which I wrote here, but then there was a plus 2 at the end. You guys may have completed the square a little differently. However you need to get to the answer, go ahead. Okay, so you know what? Let me take out these plus signs, and I am just going to like do these problems separately. Okay. I'll put the answer back together at the end. So now why did I do that? It's so that I can have x plus 1 squared plus 1. This is x plus 1 squared, and then this is plus 1. Now this is arctan. I am really going into the next problem. Okay, let me try to clean up the space here. U is x plus 1, du is dx. We love when that happens, and a is 1. A is 1 because that's squared. So then I can rewrite this as -7. This is 1 over u squared plus 1 squared. Dx is du. Final answer is going to be -7. Now, does arctan have a 1 over a? Yep, the only one that doesn't is arcsine, but a is 1. So I have -7. And then I'm going to write arctan of u over a. U is x plus 1, a is 1, plus c2. So my final answer is going to be both things put together. Natural log of x squared plus 2x plus 2 minus 7 arctan of x plus 1 plus c. Okay, on to D. This is what I meant earlier where I said I was really getting into the next problem. Look at all this. Okay, so it looks like I'm going to have to write kind of small over here. Let me just get a different color for a separator. Okay, sorry about that, kiddos. Okay, we have 2 left. On this one, what are we going to do? Look at the denominator. I'm thinking arcsecant, are you? Because we have an x, and we have a u squared minus that. But this is causing us trouble up here. So remember, arcsecant's only going to work if we have like a 1 up here, or if this, yeah, really, because look at u is x, because u is whatever squared. So the derivative of x is 1. So I need to split this up. So we have no chance of doing it right now unless we split it up. So I'm going to have x squared over x square root of x squared minus 4 dx plus, and I'm going to write the 3 in front right away, x square root of x squared minus 4 dx. Okay, going on, look at the left. Oh, look guys, so let me back up. The reason we did this, remember, because we needed, this looks like arcsecant, but we needed this to just be a number. And then look, when we rewrote it, do you guys see that canceling? Oh good, this is really picking up. So now we have x over the square root of x squared minus 4 dx. Okay, this isn't gonna be as bad. Left, always try u sub first. Again, I'm going to do this 2 separate problems, and then we'll put them together at the end. If this is u, du is 2x, and there's an x. Awesome. So u is x squared minus 4, du is 2x dx. So again, I'm going to separate this, and I'm just going to work down. So I'm going to replace the bottom with the square root of u. Let me box this off. I'm just trying to be the same as we always are. And then look what I have up here. That's gone. I have an x dx, which is right there. Great. 1/2. Oh, why was that all in pink? Let's fix all that. Okay, you guys keep writing while I'm fixing this. Okay, so back to this. I let the square root of u go on the bottom. X dx got replaced with 1/2 du. We have to make this calculus friendly, which is u to the -1/2 du. If I integrate, I get u to the 1/2 times 2 plus c1. This now, the 1/2 and the 2 cancel. I get the square root of u, which was x squared minus 4 plus c1. Okay, now onto the right side. This is actually even better. Compare this to the rule for arcsecant. There's not even u sub needed. This is the rule. The only thing to note in this case is that a is 2. Other than that, the quantity squared, like when we have to use u sub, the quantity squared is an x plus 1, but this is just an x. So we are just going to write the rule for arcsecant. Arcsecant is 1 over a, and in this case, a is 2. So I have a plus, yes, okay, just making sure I wrote this right. I have, let me get rid of that plus. I have 3, okay, because that's my scalar. arc secant is 1 over a is 2, so I'm going to go with 3/2. And then you write arc secant, and then it's absolute value of u over a. U is just x. Absolute value of x over 2 plus c2. This right side, we're done. Let's put everything together now, and it's going to be the square root of x squared minus 4 plus 3 over 2 arc secant, absolute value of x over 2 plus c. Awesome. Okay, I hope we're on our last one. Okay, guys, you know what? Actually, on E, I was looking at it, and I'd really rather us do this together in class. There's a couple ways to do it, and it's a little complicated. So let's save E, and we'll do this in class together. Okay, see you guys.